Welcome back to working with U substitution as an integration technique. Yesterday we saw how helpful picking the right U could be in simplifying your integral and coming down to something that's a lot easier to work with. So today we're going to keep working with that skill just to practice that and make sure we really understand it really well. So we're going to really practice recognizing when U substitution is helpful. So last night in your homework, for a lot of them, the book told you what the U was, and so you didn't have to think too hard about it. A couple of them towards the end, you had to choose your own. Tonight, you're totally on your own. You've got to choose the right U to go to make that formula or the integral simplify. So let's practice that a little bit more. So how do you know? Okay, 2 rules of thumb. If it has parentheses, chances are what's in that parentheses are going to be the right thing to choose for your U. So that's one thing. The second rule of thumb is if you don't see parentheses, but you see a product, so multiplication, or a quotient, so division, it's probably going to be U substitution. All right, so those are the 2 things to look for. Actually 3, parentheses, product, quotient. How do you make your good U choice? Couple things that you can use as a guideline. Guideline number 1. Look for the word of. It's usually inside of something. So the square root of, the logarithm of, e to the power of, the sign of. So if you could read it out loud and use the word of, that thing that comes after of is usually going to be your U. Now, if there's no of, or you can't figure out how to read that with the word of, then try making your U the highest power. Okay, then often that will work. So it's trial and error and it's practice, and so that's why we practice. So let's take a look at this. So this is a quotient problem. There's really no way to read this quotient with the word of. It's 2x to the third divided by x to the fourth minus 2. So I can't find the word of here. But I do see one power that's higher than the other. So that is likely going to be my U. So let's make that choice for U is the higher power. So x to the fourth minus 2. Now you want to find the derivative with respect to x. So du over dx. And the derivative then would be 4x to the third. We're going to drop a 1 under that so we can cross multiply. And when we cross multiply, we end up with du being equal to 4x cubed times dx. And we usually follow cross multiplication with division so we can get dx by itself. So I'm going to divide both sides by 4x cubed and reduce, which leaves me with dx by itself being equal to du over 4x cubed. Now we're ready to make our substitution, and you substitute both the first thing you started with and the last thing you ended up with. So let's take a look at those 2 things. The first thing we substituted here is that u is going to replace that denominator. And the last thing that we ended up with is that the dx is going to get replaced with the new quantity. All right, so we're not really touching the 2x cubed at all right now. So what will that give me? My equal sign, 2x cubed, I don't do anything with. My denominator is replaced with u. My dx is replaced with du over 4x cubed. And now I look to see if I can do any reducing. So I can reduce the x cubes, and I can reduce the 2 and the 4 to a 1 and a 2, which means out in the front of my integral, I'm going to pull a 1/2 out. That's the 1 from the numerator and the 2 from the denominator. And I'm left with 1 over u du. So 1 over that single power, okay, that's always going to be a natural log. So this will be 1/2 of the natural log of the absolute value of u plus the constant c. And all I have to do is replace u at the end to finish with the general solution. So 1/2 the natural log of the absolute value of x to the 4th minus 2, which is what u stood for, plus the constant c, and that's my final answer for my antiderivative. It all came from choosing the right u at the beginning. So let's practice again. All right, we have the logarithm, natural logarithm to the 3rd power of 2x over x. Now, it is possible to use the word of when I say this if I rewrite this. So it's this cube here that gets rewritten much like you would with a trig problem. So this would become parentheses ln parentheses 2x, and then the cube goes on the outside, just like you would with a trig problem. That's what that does. So where's the word of here? This is the cube of the natural log of 2x. Okay, so I said of twice. The cube of the natural log of 2x. So if I said natural log twice, which one do I use for my u? Well, it's the first of. So the cube of the natural log of 2x. So that's going to be my u, the natural log of 2x. So then my derivative, my du dx for a natural log is 1 over 2x. And because there was an extra of, there's that extra chain rule, so I have to multiply by 2. Those 2's reduce each other. And then I'm going to cross multiply what's left. So I'll cross multiply here. So I'll have du equals, x du, and I cross multiply, equals dx. And I have dx alone, which is what I needed. So now we substitute what we start, the first and the last. What we started with at the beginning, that's going to go in the parentheses, and what we ended up with at the end, that's going to go in for dx. So let's see what we have. So I make an equal sign, and into the parentheses goes u. I don't do anything to the x. And then for the dx, I'll have x du substituted in. So then we see that the x that was in the original denominator is going to reduce out with the x I just substituted in, which is going to give me u cubed du, which has a lovely antiderivative of u to the 4th over 4 plus the constant c. So my last step is to replace the u with what I had originally chosen. So the natural log of 2x, that quantity will be to the 4th power over 4 plus c. So that's the general solution using substitution. So practice makes perfect. Let's just keep practicing. All right, here we have a cube and a square. So we have the cube of tangent of x and the square of cosine of x. So we have 2 powers, both with we say of. So we're going to choose the higher one. And so we're going to pick, you would understand that this means parentheses tan x, quantity with the cube on the outside, and parentheses cos x with the quantity squared on the outside. So when you have 2 ofs, so the cube of tangent of x over the square of, so I said of twice, pick the higher power. So my u choice would be tan x. So my du dx will be the derivative of tangent x, which is secant squared. We'll put a 1 under that so we can cross multiply. So that's going to give me du equals secant squared x times dx. And then I want to divide because I always want to go until I have dx by itself. So divide by secant squared, which reduces. So I have dx by itself. And then I have du over secant squared. But remember that secant squared is an identity, so we don't really want to leave secant squared in the denominator. That would be the same as putting cosine squared in the numerator. So that's always a better option, is to write it as a numerator. Okay, so now we have dx by itself, so we go back to the beginning, and we're going to put u in for tan x, and we'll go to the end, and we're going to replace dx here, and we're not going to do anything with the cosine squared x right now. So in our parentheses, we'll have u cubed. We're not going to do anything with cos x quantity squared. And then we're going to replace cos squared x dx for the, du. I wrote it wrong on both places. I wrote it wrong over here. Fix that. That should be a du and should be du right here. Okay, then we reduce. And our cosine squared x is going to reduce the cosine squared x, leaving me with simply u cubed du, which is what we had last time. And so we end up with u to the fourth over 4 plus c. So then we'll trade out what our u used to be. So that would be tan x to the fourth over 4 plus c. Or you can put that to the fourth, you can tuck it in right after the tan if you want. That's another way to write it. It's the same, it's equivalent. Either with parentheses or tucked in after the tangent would be fine. All right, this next problem is a little bit unique because it doesn't have an of in it, and it doesn't really have a higher power either. We have a denominator, though, that has an x in it and a numerator that doesn't. And so the one that has an x is going to be higher than the constant of 3. So my u choice this time would be the denominator 5 minus x. So my derivative, du over dx, would be the derivative of 5 minus x, which is negative 1. And then we'll put a 1 under it so we can cross multiply. And we'll have du equals negative 1 times dx. And we'll divide away that negative 1 so that we can get dx by itself. So that turns out to have dx alone, and then du divided by negative 1 is negative du. So from the beginning to the end, we'll substitute. So we'll take our u being 5 minus x, which is going to get substituted here. And then our dx will get replaced by negative du, and we're not going to touch the 3 yet. So 3 would be over what we chose for u, and then the replacement is negative du. So there's no reducing here, but I can pull a few things out to the front of the integral. I can pull the negative out to the front, and I can pull the number 3, which is going to leave me with 1 over u du. And that 1 over u is that special case where we have a single term in the denominator, which is going to be the natural log. So we'll have negative 3 of the natural log of the absolute value of u plus the constant of c. And then replace your u with the substitution 5 minus x in the absolute value plus the constant of c. All right, we're about 15 minutes in. I think just one more, and then you'll be good to try the rest of them on your own. So here's another chance for us to use substitution because this is a product. It's a multiplication. So remember, multiplication or division, we just did a division one. Multiplication or division or parentheses. We've got the word of here because we have x to the power of 2 and e to the power of x cubed. So we have two ofs, and we would choose the one with the higher power. So u being chosen to be x cubed. So then du over dx, we would have the derivative 3x to the second over 1 so that I can cross multiply. Giving me du equals 3x squared times dx. And then our goal is to get the dx alone. So we'll divide by 3x squared. And we'll reduce. So dx alone is du over 3x squared. And now we're ready to replace our beginning and our end. So our beginning, u being equal to x cubed, that'll be right here. And then our dx at the end, that'll replace dx, and we don't do anything with x squared yet. So x squared times e to the replaced u, and then dx would be du over 3x squared. So now you can see that the x squareds will reduce. And the only thing I can do with the 3 is pull it out to the front, but it's in the denominator, so that would get pulled out as a 1/3. And I'm left with e to the u du. And e to the u du has a perfect antiderivative. That antiderivative is e to the u divided by the ln of e and the chain rule of of u, which is 1, plus c. So let's finish this up. Remember that the natural log of e is 1. So we have 1/3 e to the, and then u was x cubed, and then plus c is your final answer. So all of these u substitutions should work out perfectly. Everything should reduce so nicely, and you should end up with a really simple integral at the end. If things are not reducing nicely, if you don't end up with a really nice u expression, then that means your choice of u at the beginning wasn't right. So go back and try again. Maybe you chose poorly. So just keep an eye out for that, okay? So work on this, finish this up on Friday, and take the weekend to take a break, and then we'll come back Monday working together on expanding this idea of u substitution. All right, I'll see you Monday.